Alright, here we've got our third video on exponential and log equations. And so on this one, to start off, I've got some ideas that I want us to keep in mind. And the first is that if the log of A equals the log of B, then A must be equal to B. There's no way those could be different numbers if their logs have the same value. They'd have to have the same value themselves. That's a little tool I want you to have in your tool belt. And we also can't take the log of a negative value. And so real quickly, just to give you a very basic unpacking of this idea, we know that 2 raised to some power is 4, and you're like, okay, well, that must be a 2. And you can even do a 1/2 if your exponent is a negative 1. So remember, a negative exponent flips it. But what would the exponent have to be for you to get a negative number? Now you gotta be careful because you might say, oh, well, that's just 2 to the negative 4th power. But 2 to the negative 4th power is 1 over 2 to the 4th power. And so what we find out is that if I have a positive base, there's no power I can raise it to that would give me a negative answer. And so if I were to rewrite this in logarithmic form, that would be log base 2 of negative 16 equals x. Meaning that if you have a negative number there, that's bad. Okay, you can't have that. And so I want you to kind of store that in your memory base, that this number cannot be a negative, because by writing that, you're implying that a positive base raised to a power could have a negative answer, and that is just not going to happen. So now that with that little background information in mind, let's jump into some examples. So I'm looking at this example. We have the log of x plus 6 plus the log of x plus 2 equals the log of x. Now the first thing that I see, and once again this comes with experience, the more videos like this you watch, the more you'll be able to see it, is I see a plus sign right there. And one of our log properties is that if you have the log of A plus the log of B, sorry, that's not very neat writing, that's equal to the log of AB. It's equal to the log of the product. And so that's what we're going to do here. I can rewrite this as the log of x plus 6 times x plus 2. Okay? And that's equal to the log of x. Now, the other idea that we can use here is that idea that I mentioned in the previous slide, that if the log of A equals the log of B, well then it follows that A must be equal to B. So if the log of A, this is like our A, equals the log of B, then we know that x plus 6 times x plus 2, our A value, must be equal to our B value. And so by doing this, I've just rewritten, using our properties of logs that we know, I've rewritten this as a normal equation that we can solve. So the first thing I'm going to do is I'm just going to kind of distribute this thing out, and I get x squared plus 2x plus 6x plus 12. And I can combine my like terms. And then I'm going to subtract 1x from each side just to get, because this is clearly going to be a quadratic, so when I solve quadratics I want them to be equal to 0. So that's going to become x squared plus 7x plus 12 equals 0 once I subtract that x from each side. And this quadratic, now we're kind of back to Algebra 1, solving a quadratic. You can solve this using whatever method you choose, but I'd probably just factor it, and I'm not going to go into the ins and outs of factoring because that's not the focus of this video. But you could solve it with quadratic form if you wanted. And so if we have x plus 3 equals 0 and x plus 4 equals 0, well, once I solve those, my solutions are -3 and -4. Now, with these problems, it's always wise to come back up and check your answers, because as I'm coming back up here and wanting to check it, remember, from that previous slide, we can't take the log of a negative. So if x equals -3, in this very first step of my problem, I'd be taking the log of -3 right here, which is undefined. We don't have a number that satisfies that. So because of that, this would be a no solution, because neither one of the two solutions that we got using algebraic methods would work right here, or over here for that matter. Okay. Let's look at this one. And so as I look at this problem, we have log base 2 of a whole bunch of stuff equals 3. And so the first thing I'm going to do when I look at this problem is I'm going to rewrite in exponential form. So if I have the log base a of b equals x, that can be rewritten in exponential form as a to the x equals b. Whatever number was the base becomes the base for the exponent, and then whatever number was on the right side becomes our exponent. I think I may have misspoke there, but you get the idea. So if I were to do this, I could rewrite that as 2 to the third, 2 to the third equals all this other stuff. And now, because I was able to rewrite this in exponential form, we have 8 equals, let me kind of distribute over here on the right side. So we have 3x squared minus 12x minus 7x plus 28. And so what I'm going to do is I'm going to combine like terms and get minus 19x. And I'm also going to subtract 8 from each side to give me a 20. So here is the quadratic that we're really trying to solve. We're trying to solve this equation 3x squared minus 19x plus 20 equals 0. Now, I am once again not going to go into the ins and outs of factoring for the sake of time, but I'm going to solve this by factoring. You could also solve this with quadratic formula or graphing or whatever quadratic solving thing you like to use best. But whenever I factor this, I get x minus 5 times 3x minus 4 equals 0. And so whenever I solve that, we have x minus 5 equals 0 and 3x minus 4 equals 0. So if I solve this by adding 5 to each side, you get that. To solve this, I'm going to add 4 to each side, and then I'm going to divide by 3. So we have two solutions, and if I come back up here, I don't think either of these solutions would result in us having the log of a negative. And I want to unpack that because it's a little bit tricky. So I put in a 5, 15 minus 7, okay, that's a positive. 5 minus 4, okay, that's a positive. So the 5 seems to be a good solution. But let's look at this 4/3. If I put in 4/3 here, you might think, oh, 4/3 is less than 4. 4/3 minus 4 would give us a negative. So if I put in the 4/3, this would give us a negative. Now, but here's the issue. If you put in a 4/3 here, it would also give you a negative. This expression would become, I think, a negative 3. And so if I had another negative there, what's a negative times a negative? Well, by putting in 4/3, we would still be taking the log of a positive. So that means that 4/3, tricky as it is, still seems like a good solution to me. So our solutions to the second one are 5 and 4/3. Let's do our last example. Oh man, there's all sorts of stuff going on here. We have the natural log of e to the natural log of x minus the natural log of x minus 3 equals the natural log of 2. So whenever I see this problem, the first thing that jumps at me is I've got this exponent right here. And one of the things we know about properties of logs is that the exponent can become a coefficient out in front. So if I have the natural log of x times the natural log of e, and I'm just going to copy down the rest of this stuff, minus the natural log of x minus 3 equals the natural log of 2. Now, the natural log of e, those are inverses. So now I'm left with this. I have the natural log of x minus the natural log of x minus 3 equals the natural log of 2. And hopefully what you're doing after watching the other videos is you're seeing that minus sign right there. And you're saying, oh, we have a log property about that. And you do. We know that if you have the natural log of a minus the natural log of b, that's going to be equal to the natural log of a over b. You could write it as a quotient. Okay? And so that's exactly what we're going to do here. I'm going to write the natural log of x over x minus 3 equals the natural log of 2. And now we're using the property that we used earlier. I think I used it using the common log. I'd say log of a, if log of a equals log of b, then a equals b. But now we're doing the same thing, but instead of the common log, we're just doing it with the natural log. Okay? And so here, basically, if the log of this equals the log of this, well then we know that this thing must be equal to this thing. And now let's just solve our little equation that we got. I'm going to multiply by x minus 3 on each side of my equation. So it's going to cancel there and leave me with x equals 2 times x minus 3. And then I'm going to distribute. I'm going to subtract 2x from each side. I'm going to divide by negative 1 on each side. So we get x equals 6. I'm looking up here. I don't think this results in a negative because if I put it in there, 6 minus 3 would give me the natural log of a positive. I think this is a good solution, and then it's nice that we only have one solution after the quadratics that we did earlier.